All right, this video is going to help us understand why we have multiple ways to solve systems. The problem you have on the screen is asking us to solve this system by graphing. Now, you might take a look at those equations and go, that is a pretty messy set of equations. And really, that's where graphing kind of has its downfall. So I'm going to kind of walk you through very quickly how we would graph this so you can see how much work that it takes, and then help us to understand that there are faster and better ways to graph, or to, solve systems as far as this goes. So the first thing I would do is take a look at it and say, okay, well, we could try to do the standard form method of doing some intercepts, right? We could sort of insert 0 for x and sort of block things out and find intercepts and try to graph. However, we may not be the most accurate graphers at that point. And so what I'm going to try to do is use y equals mx plus b. We use our slope-intercept form. So I'm going to take this top equation, and the first thing I'm going to do is I'm going to multiply both sides of my equation by 4. And I get that 4 using those common denominators. 4 times 3/4 x, plus I'm going to distribute that to my 1/4 y. And again, I can only multiply something on one side of an equation if I multiply it on both sides. So I'll also multiply that 13/2 by 4. So that'll give me an equation of 3x plus 4 times 1/4 would be a 1y equal to, again, 4 times 13/2 is going to be 26. Then I'm going to go ahead and subtract 3x from both sides so that I can get y equals negative 3x plus 26. And you'll notice immediately, well, I've got to get all the way up to 26. So a couple of graphing hints on this one. I'm going to count by y's by 3, so that again on my graph that takes me all the way up to 30. So again, that would be 27 would be the line right below that, and 26 is going to be just below that line. It might look a little bit more like a halfway point, but again, it should be about a third of the way down there. 26, 25, and 24 again would have been the actual line. Then I'm going to go down by 3. So again, my slope of negative 3 here over 1. So I'm going to drop down by 3 and go over 1. Right, again, down by 3 over 1, 3 over 1. Again, remember I'm counting by 3s, whereas on the x-axis I'll count by 1s. I'm going down 3 units at a time though, so again, a third of the way below each one of those lines. As you can tell already, that means I'm not exactly perfectly accurate, but again, I should get a pretty decent looking line that hopefully will help me find the solution to my system, right? That one point that's going to make them both equations true. Now let's take our second equation and let's actually do the same thing, looking at those common denominators. I'm going to go ahead and take 4 again times x minus 3/4 y, and 4 multiplied by the right side as well, which we already know is going to be 26 because that's the same 13/2 we had in the first equation. Then by distributing here, I've got 4x minus 4 times 3/4 would be minus 3y. Subtract that 4x to the right side. All right, so it's going to be a negative 4x over on the right side. Then I'll divide everything by negative 3. So y equals negative 4 divided by negative 3 is a positive 4/3 x. And 26 divided by negative 3 means that's not the prettiest of numbers. But notice I also gave myself a little bit of a hint. If the y-intercept's not going to be a great place to start, then let's just find another point. Right? We could try plugging in 1, because positive 4/3 times 1 minus 26/3 would be negative 22/3. Now that's not the prettiest point to try to plot. But I could also go ahead and say, well, why don't we plug in x as 2? 2 times 4/3 would be 8/3, and 8/3 minus 26/3 would be a negative 18/3. Right? I'm going to go ahead and write that over here on this side. 4/3, again, times 2 is 8/3. But again, then we're subtracting 26/3, which gives us a negative 18/3, which would actually just be negative 6. That's a good point to plot. 2, negative 6. Now remember, we're counting by 3's in the y direction, so negative 6 is actually just the second line down. We're going to be right about here. Then using my slope of 4/3, I could go up 4, write 3, Up 1, 2, 3, 4, right 1, 2, 3. And I think that actually gives me a pretty decent point. Looks to me like our solution is going to be 8. And we're up 2. And again, you could plug those points back into your equations and make sure that they work. Now, like I said, that probably looked like a very messy process. We had a lot of fractions going on. That doesn't make graphing very simple. We had to count by a large number because, again, our y-intercept wasn't very helpful. But again, we get that solution of 8, 2. Let's take a look at this using a different method, using that method of substitution. Now, I'm not saying it won't be a little bit messy, but again, we think we're going to get a solution of 8, 2. So I'm going to go ahead and write that up here just so that we can check our answer. Let's try this one by a method of substitution. Now, substitution is a little different algebraic method. We need one of our equations solved for one of our variables. So again, looking at this bottom equation, solving for x would be fairly simple. So I'm going to go ahead and say x equals. I'm going to add 3/4 y. Right? I'm going to add that 3/4 y to the right side, which means x equals positive 3/4 y, again, plus that positive 13/2. Now, I know that's got a bunch of fractions in there, and in the first screen, we multiplied by a common denominator, made some equations without all those fractions in there. I'm not going to worry about that. If I know what that x equals this equation right here, well, then we can insert that into the top equation. 3/4 times x, which again we know is 3/4 y plus 13/2. I'm just taking out x and I'm plugging in what it's equal to. Then we have to add on our 1/4 y and equal that to 13/2. Again, that's just this top equation, taking out x, plugging in what we know x is equal to, right? We've got this equation down here that x equaled, so we just plugged it in for x, right, in our equation right there. Now we just have some arithmetic to do. Again, we've got calculators, or you can do these in your head. I'm going to go ahead and distribute my 3/4 to both parts here. So we're going to get 9/16 y plus 39/8, right? Multiply the tops, multiply the bottoms, plus. Now notice I've got a y value in that first term. I also have a y value here, and I'm going to add those together in just a minute. So what I'm going to go ahead and do is use a common denominator. I'm going to multiply the top by 4 and the bottom by 4, just so that both of my y values are in 16ths right now. Just thinking ahead a little bit, I'm hoping that will help out. So 9/16 plus 4/16 would be 13/16 of y plus 39/8 equal to 13/2. In that case, I'm going to go ahead and subtract my 39/8, right? Not the prettiest of numbers, but again, it's just a fraction. So again, we're back to 13/16 of y is equal to, again, if we're going to multiply the bottom by 4 to make this into an 8, I need to multiply the top by 4, which is going to be a 52. 52 minus 39 is 13. So I've got 13/8 over here. Again, you can use your calculator to handle that arithmetic, but again, you're just subtracting a couple of fractions. Okay, just taking 13/2 minus 39/8. And now let's multiply by the reciprocal. If we multiply by 16/13 on the left, we'll get just y. And multiply by 16/13 on the right, which is kind of nice. The 13s cancel out of both sides here. The 16s cancel on the left, giving you y. 16 divided by 8 is 2. Notice we've already matched up with our y value that we wanted, and we have half of our answer. Now, there's a little fraction work there, but I would argue that that was probably a little bit easier, other than the fractions, right? This basic arithmetic was a little easier than trying to figure out how to graph those messy equations. All we need to do now is insert our y back in here, and notice we have a nice equation, x equals 3/4 times 2 plus 13/2. So therefore x equals 6/4, or 1.5, plus 13 halves, which is actually 6.5, and x equals 8. Again, just like we thought it should be in our equation, or our answer up there. Now again, I know there was some fraction work there. Don't let that scare you off. That's really just some basic arithmetic. But again, I would argue that we're a little more precise, right, graphing this algebraically compared to doing this graphing-wise, right, on that first screen where we had to guess a little bit. We had to be really careful with how we intersected our lines. I would say it's a little more accurate and a little more straightforward, just solving by substitution. So again, that's the why of substitution. Again, there's another video I've made that's the how, probably a little bit simpler examples. So feel free to watch that video to show you the basic steps of solving by substitution. Have a great day.